And if you wanted to end up with a 90, you would do this. So you would do 0.35 times quarter 1, 0.35 times your quarter 2 average, 0.3 times any possible exam score to get 90. Or calculate this out, subtract it from the 90 and divide by 0.3. Alright, so what are we looking at pattern-wise here on page 324? We're talking about n behavior in degrees. The general shape on a graph of several polynomials show the maximum number of times the graph of each function may intersect the x-axis. This is the same number as the degree of the polynomial. But the number of times the graph intersects the x is the same as the degree. Let me give you an example. This first graph is a flat line. I can make up an equation that goes with it. It's just y equals 3. No slope. 1, 2, 3. So the degree here is 0 because there is no x. Alex R., can you make up an equation for this? For this? No, x squared is not going to be straight line. Okay, I'll take it. Let's do x plus 2. So the intercept is at 2 and it has a slope at 1 over 1. What's the degree of this x? It's got an exponent of invisible 1 and it crosses the x-axis once. Can anybody just put your devices away, all 3 of you? You're 3 of the only people who look at their phone. Like, put them in your backpack because you're just going to look at them again in 2 seconds. You can do it, Mark? Let's hear it. I'm going to say x squared plus 3 because it's a parabola. And that means it's got to be x squared. And one more thing. It's actually y equals negative x plus 3. Right? Okay, very good. Now, this is x squared because it's a U shape. The degree is 2, and look at how many times it crosses the x-axis. 2 places. That's not a coincidence. Okay? This one down here is called cubic. An example would be x to the third plus 2x squared, so on. It's a cubic function. Its exponent is 3. And how many times does it cross the x-axis? 1, 2, 3. Not a coincidence. This is a 4th degree function. Y equals x to the 4th minus 3x to the 3rd, and so on. And look at 1, 2, 3, 4 x-intercepts. Those are called Brill zeros. So if this is a 4, the most a line will go through this axis is 4. This equation could never go through 6 times. It won't happen mathematically. It'll go through a max of 4. So this one's called quintic. So an equation would be y equals x to the 5th minus 4x to the 4th plus 3x to the 3rd. And look, it goes through 1, 2, 3, 4, 5 times. So all you have to figure out from this is that if you know the exponent, you know the maximum number of times the graph will go through the x-axis. It matches. Alright, can anybody make a statement about this? Can anybody put that in their own words? This pattern, this truth about graphs and equations. Anybody? Go ahead. Okay, thank you. You did it. The exponent matches the number of times the line passes through x. This is what I said. The maximum number of real zeros matches the degree. The textbook says it, the textbook says it another way. So you have to kind of land on an understanding of it. So, and we're gonna continue talking about this. So if you still don't get it, it's okay. Ready for another example of patterns? All right, so somebody in my earlier class said it looks like someone drew these with like bad goggles on or something. But the truth is, most real data, when it's graphed, doesn't make a perfect straight line, and it's not symmetrical. It's just up until now, most of the data you've worked with has been symmetrical in a straight line. But polynomials opens that up. So just take a look, try to figure out what these patterns are, and write some statements about the patterns, if you can. So both of these are even degrees, this one and this one. So this would be like x squared, x to the fourth, x to the sixth, and this would be negative x squared, negative x to the fourth, and negative x to the sixth. What can you say about what those have in common? This is just x to the first, x to the third, x to the fifth power. And these are negatives. Negative x to the first, negative x to the third, negative x to the fifth. What could you say about those? I'm going to give you a time. Try to make a statement. Write down a statement. You got it? Sure. I'm gonna walk around just a minute. Alex, if you want to stay after school, I can teach you on the skateboard division in probably about 5 minutes. Or if you watch the video, I actually posted some Khan Academy. Alright, anybody notice any patterns up here? Here, what?
I don't know how to word it, but I said that all the odd ones are going in like 2 directions, and all the even ones are in one direction.
That's it. That's what we're looking for. Did you see it, baby? You see the odd ones? What are the odd ones doing? No. That's not what I'm talking about. Listen to Mark. He said it. All the odd degrees, so these ones down here, have ends going in opposite directions. So it's kind of handy that odd and opposite start with O. Odd degree go opposite ways. So if you have an equation that's x to the third, I'm going to ask you to graph an x to the third and x to the fifth equation. You have to know that the ends should go opposite. There isn't anything in the math that's going to tell you that. You're going to fill in a table and plot it. And if you have both your ends going the same way, it's because you don't understand end behavior. So x to the third, fifth, seventh, ninth, 11th, forever, the ends will go opposite. The even degrees have ends going in the same direction. So it's very easy for me to see if you've graphed a polynomial correctly. If it's a fourth degree, the ends need to be going both up. Or if it's a negative fourth degree, the ends both have to be going down. Okay? So odd exponents go opposite directions, even exponents go the same. Okay, here's some more statements. So if it's an even degree and it's positive, both ends will go up every time. If it's an even degree and it's negative, both ends will go down every time. These are truths that you can rely on. And then if it's an odd degree and it's positive leading coefficient, it has a positive slope. So even if it's y equals x to the fifth, which you've never graphed before, it's going to have a positive slope, meaning start low and end high. But if it's odd degree and negative, like y equals negative x to the fifth, it's going to start high and end low, like a negative slope. Okay? So, like in the curriculum, we spent all this time graphing perfectly straight lines and understanding positive and negative slope. And then we spent all this time graphing perfect parabolas that go up or down. And then after that, they just lump it all together. Now that you know those two really well, you could do all odd degrees or all even degrees with just a few skills. Any questions? Okay. So we're going to do one more thing with this, but let's just look at Friday's homework answers first. So get out your homework from Friday. I think you had time in class to do it. Here's the answers, the remainders. Don't mind the happy hour. I'll let you know when it might not be I don't think so. How to do it? Did you get that right? Okay. Yeah, I can type it. I don't want to read that. You know your remainders and checking your work. I don't want to. Yeah. Let me just highlight this again. Yeah, you guys see the picture. If you want more details, take a picture.